I'm ChosenArchitect, and this is ProjectE 2. I'm just preparing you because today is going to be a pretty significant video. We're going to talk a lot about applied energistics and how we can utilize and expand on our channels, aka point-to-point, or P2P as a lot of people will call it within applied energistics. Last few episodes here in our ProjectE world, I have expanded and added some custom dimensions, and these dimensions open up and expand into some very large structures that we built last episode. But these right here come with a problem. They're in another dimension, and applied energistics doesn't exactly make it super easy to, for example, move your network from one dimension to another. So what we've already set up is the cross-dimensional travel using the quantum ring. Now, these are not linked yet, and we're going to do that here in a second, but essentially you need to have a multi-block that is connected to your main system in your main world, and then in your world that you want to bring your network to, you also need another quantum ring. And inside this slot, we are going to be making some quantum entangled singularities, these things which do split up from a regular singularity, and I have shown how to make that throughout the series. It's actually pretty easy. You can just feed water into the matter condenser and you will have more singularities than you'll ever need. But we're going to get that all linked up here in a second. But what I've done is I've just ran some dense cables. Now I have some interesting logic around how I am going to handle my channels using that point-to-point system. And my logic essentially consists of carrying out these dense cables, which is going to carry our default 32 channels. So in reality, we're only sending 32 channels into these dimensions, but we'll have access to a ton more channels from our controller by utilizing that point-to-point system. But we need those initial channels over there, and so I'm getting them from these wireless connectors. Now you're thinking, why don't you just use the wireless connectors? Well, unfortunately, these are not cross-dimensional, and they actually start to cost way, way more the further out you go away from the other connector. So the linear cost is very high, and I would end up with a problem where even if I had this 32 channels to basically work with, I only have 32 channels in that dimension, and that's it. And that is not going to be enough. So what I'm going to do is I'll utilize the 32 channels that we are innately getting to just simply power the point-to-points, which do take up one channel, but they will generate 32 channels, of course, per point. And of course, I'm going to try my best to explain this and show this to you in the best way possible. And I think there is a really good example. So if you do P2P and we go ahead and look at the guide by hitting W on this, which is what I have it set to open up the guide, this little illustration right here, like just basically think of these as the points. And essentially you have the cable that is coming off of a controller on a dense cable, and you have that connected to a point, right? And it's directly connected to the cable, and it's just a direct tunnel that leads in. So this network right here is the same representation as this that you see here, where it is just a direct gateway from one location to another. And yes, that means like nothing in between. It is just a portal from one place to another with nothing in between. And I think the best way to show that is with redstone, or think about it with redstone, right? Because there is a redstone P2P. And essentially, if you sent a redstone signal of 15 and you had it linked to another one somewhere else on the network, it would also be outputting a redstone signal of 15 with no degrading in redstone signal. Now let's go ahead and make our quantum entangled singularity so we can get our networks linked together. And that is going to be a singularity with an interpearl and a tiny TNT. And this, by the way, is also going to be another mechanic that we'll be using later on as well, later on down the line. But we essentially just need to blow these things up, and boom. Now we have an entangled singularity, and these are going to be stacked in pairs because they are linked to one another. I'm going to go ahead and label this for right now, and using a framed sign, I'm able to get that nice there. I think later on I'm going to exchange these, and I want to have like a frame directly in here, but this one is going to be directly connected. So let's go ahead and place that quantum entangled singularity in here. And what we should do is we should be able to go into our mech dimension, which is one of the mods that I definitely want to start with. And let's go ahead and run down here and place it in this one. So when we do this, this should fire up and it says network booting. And now we have the device online. And right here in our cable, you can see 0 of 32 channels and the device is online, powered up, and we should be ready to go. Now, starting with this side, I'm going to use my travel staff to sort of teleport through these walls here. And I just want to expand this along the bottom here, utilizing these green dense cables. And of course, normally if you had to handcraft dense cables, you probably wouldn't be using them like this. But I kind of want to get them to the position where we're actually going to be utilizing them. So I think this position right here is going to be great. So that way we can split off 16. Well, actually, we can split off 32 individual channels, meaning we could have 32 individual point-to-points that would each be able to carry 32 channels each. But of course, that's assuming that you had enough sides to your controller to do that. But I think with this is going to be fantastic. So now I think while I'm trying to show off the point-to-point and how all of that functions, we're also going to be getting all of the mechanism automation that we set up prior with just like 1 or 2 machines. And now we're going to really go overboard. And I'm going to show you how you can actually go incredibly overboard, making things insanely fast for automation within Mekanism as well. And so down here, I have planned out all of the different alloys, steel production, and all of the enrichment versions of things that we are going to have set up down here, which is what my initial plan was, to use this down area here for all of this automation. That's why I gave myself a teensy bit of room back here. And I should be able to pop into here. There is room back here, I promise. There we go. And yes, we'll have a machine, I think, sticking out the wall here, but all of this will be facaded. Yeah, because this is the outer wall. But what I want to do is I want to have 4 machines. So if I, for example, take this obsidian here, I want to have a pattern provider be able to send the pattern and request the items. And then on the outside, I'm going to have 4 of the individual machines. That's going to be pretty darn cool. So I've got to keep in mind how many channels is my setup going to cost. And so the pattern provider will be in the middle. And that means I'm also going to need some exporters, which are going to constantly be able to send. And now these are going to be on like a subnet. I'm going to explain that as well. We're going to get into some subnets. But essentially, I need to keep this constantly supplied with its secondary product. And so all of those products will initially basically send with our Applied Energetics system, currently our main channels, we're going to send it the raw materials, for example, diamonds, right? And then the output will just carry those things over on a separate subnet, which I'm going to, like I said, explain here in a minute. And so that means I really only need to worry about 1 channel on the main system for this whole setup. And now I do have 12 individual machines, technically, or 12 processes that are going to be taking place for this to happen. So I should be able to simply tap in to one of these. We can tap in on the north side, down on the bottom here. So let's go ahead and pop down here real quick. And what I need to do is just get a cable strand that runs down here that will be able to supply the center point, which will be right here. So let's grab a cable and let's go ahead and get this started. So I'm going to be attaching a normal cable off the side, because if we're going to attach like ME devices, including point-to-points, we are going to need to use this cable. So let's go ahead and start with a point. So right here, I have a point, or a P2P, and let's go ahead and get our shrinker. That's going to make things a little bit easier on me. I should have my shrinking device somewhere around, literally in my inventory. Okay, and I'm going to place this right here onto a block. And so what this is, essentially, is it's all linked to nothing. So the way we link it is by utilizing a memory card. So we shift right click and it says new device configuration created and copied to the memory card. And so this has created a frequency, and you can see that within Jade. It's C4CD. We don't have to worry about any of that, but we do need to know that whenever we get this set up, it is going to consume 1 channel. You can see 1 channel of our total 32 that we have available running just off of this. Now, we have to keep in mind, we only have 32 to play with around the entire thing. So 32 on this side, 30, like it's just 32 total. So by me consuming that one, this one only has 31 left, right? So we got to keep that in mind, but thankfully we'll be able to bring 32 channels to this location right here. But to do this, we have to go back to the overworld, and we are going to connect this to one side of my controller. And I have it set up in here. It's going to be very bright, by the way. One side of this right here can attach to these. So I need to kind of choose a side. For example, if I'm going to go north this way, I need to figure out on these cables where I'm going to place my controllers. And I think right here might be a good spot for my first one. So let's place this right here. And that means I need to take a cable and I just need to run this cable off of here. Now this is going to connect up here and we can use a cable anchor to actually prevent that. That'd be pretty easy. So I can just slap a cable anchor there. Now we know that it is just directly connected off of this line of 32. And that is going to basically, this one side of the controller is going to carry all of the channels that are required for this P2P. And then to link it, all I have to do is right click, not shift right click, just right click. And now this is creating a portal from the other dimension that is just simply accessing this one side of this controller. And that's basically it. So I don't think it's super scary, but it does require a little bit of logical thinking in order to kind of plan out what you're going to be doing with this. Now back over here, what we can do is we can now carry our line. You can see right here, this is carrying 32 channels now, but they're separate from here. And typically you could color this something different. But in my case, I know that this is going to be here and I know it's a separate line and I'm just going to run this along the bottom like so, all the way around. Now, the more I do the math, just to have 4 machines per process, so we're going to have 7 infusers and 5 different enrichment chambers processing, I'm going to have several machines, and I want the top of them to be receiving with exporters the ingredients. Now, I could actually get away with using providers, like, and that actually might be a little bit cheaper on me channel-wise. And you know what? I think I'm going to actually do that. So essentially what I will do is I'll have my provider, and I think it'd be best if I actually clear this off, because the way I'm doing it, of course, with decorative kind of stuff, it does make it a little bit harder to kind of show and demonstrate what's actually going on. But the more I think about it, if I was to just use exporters, I'm going to need 4 exporters per process. But if I instead, with Applied Energistics, utilize a, let's see, what is it called in Applied Energistics? Because there's a bunch of different, I kind of go back and forth with Refined Storage and Applied Energistics. I think it's called a pattern provider? No, that's right here, ME interface. So if I use an interface, what I can do is I can set the value there and I can just use pipes to just constantly keep it stored. And that actually would be a lot cheaper because this only uses 1 channel and allows me to send out to all 4 machines. You know what? That actually would be a little bit easier, I think. Now, the only issue though is if I have a pattern provider right here, I don't want the pattern provider to accidentally send my interface, and hopefully this is blacklisted. I hope it doesn't send the interface the requesting patterns. I'll actually have to test that. So I actually saved quite a bit of channels. Instead of using exporters on all of these enrichment chambers, essentially what I've done is I've used a regular logistical transporter, so a pipe that is going to send to the back of these, and it's going to pull its ingredients from the interface. Now, unfortunately, an interface doesn't directly send things to inventories. Otherwise, this would be very, very nice. I don't think, yeah, there's an induction card, a crafting card, and a fuzzy card, but there's no like exporter card, which would be kind of cool if the ME interface could forcibly send with maybe like a button to force send. That'd be kind of cool. But anyways, unfortunately, it cannot send, so I can't set it up that way. But I've just used some pipes, and we are going to need ourselves a configurator. And the configurator, if I don't have one already, which I'm kind of surprised I don't. There we go. That'll get charged up. We can go ahead and hit in, and we can change its mode. By default, we just need it to be, I believe, in wrench mode. And I'm going to shift right click. Oh, nope. Wrench mode actually removes it. Okay. So we need to be in item mode, I believe. Item. There we go. Item mode. And then I can shift right click the bottom here. Hard to see, but I need to click it twice and it's going to put it into pull mode, basically pulling it out of that as if it's a chest, which is kind of what the interface acts like. Kind of acts like a chest, basically. And you set the items in here. So because this is connected, this one is going to be for redstone. If I go ahead and I add redstone to this and I put it in this slot, it's going to keep redstone in here, and we can set the stack size to, for example, 64. And it'll always keep 64 in stock. And whenever we set these up correctly, you can see by default, it's already going into here, but it should keep this stocked. But we don't want the redstone going into that slot. Yeah, we will get all of this set up, by the way. And all we should have to do is use one configuration card to essentially set all of our machines We just have to do that here in a second. Now on these enrichment chambers, I'm gonna wanna output to the top of the machine, and we're gonna have an interface and pipe into that interface, but it's actually gonna be on a subnet, and the bottom here is receiving the input. So these are gonna already start kicking off. They have a little bit of power stored in them from me. I haven't powered them yet, and for good reason. We'll talk about that here in a second. But with that set up, we should be able to copy this. Even with these turn different directions, we should be able to shift right click with one of the configuration cards, and I should be able to right click this on here. And even with it turned like this, that shouldn't matter too much. The only thing that matters is the actual sides. And thankfully these are set up to the right, the left. So no matter what orientation the machine is in, it is going to reflect that. And so I can simply paste this to all of them, and all of their orientations are the same as the first one. Well, not exactly. The configuration is all going to be the same. And that goes for every configuration for all of these machines. For example, this one, the only one that is an outlier here is going to be the enrichment chambers that are for this right here, the enriched obsidian. And for good reason, because this is actually going to be processed through our subnetwork that we're going to be setting up. I guess while I'm at it, I might as well set up the metallurgic infuser. You can click this button, by the way, right here to clear all of the sides, which I recommend, and also set it to auto eject. Same for the other one. What we're going to do is this is going to be input output onto this. Thankfully, these will auto send ingredients, and then it'll also accept the items back in. But we are going to be sending through the top of this machine the extra. And this is what makes automating Mekanism alloys a little bit more challenging, because you do not have a input, output, and extra slot. So you have to access another face of the machine in order to do this. And for example, I'm going to be using it on the top, and we'll deal with that also with our subnetwork. So now I've been mentioning this subnet thing for a little bit. So let's actually dive into what a subnet is and how I'm going to utilize it in this build. So what I've done is on top here, to go with the color scheme, I have placed in some purple dense cable. And this is a separate line. It's not connected to our main system at all. And the cool part about Applied Energistics is you can create these subnetworks that will transport items and information around. And you can even access all of your items from your other network without even being on the same channel network. And now I really love showing this off because it really demonstrates, even though we're not going to need it for this setup, it really demonstrates how flexible Applied Energistics is. For example, the only thing that I'm going to have connecting these two networks, right, is going to be a quartz fiber cable right here. This is essentially just powering this one line of the dense smart cables. And now this dense smart cable is not carrying any channels, and what I can do is I can throw in a controller here. So if I throw in a controller, now we have 32 channels, and these are 32 new fresh channels. It is pretty interesting. And on the other side here, what I'm going to do is I'm going to break this line here, and now I have 32 channels here and 32 channels here that are on two separate network lines. So we've just expanded our channels even more just by connecting power up to a new controller that's on another network. But what if we want access, for example, on this new network to our original storage? Well, all we have to do is simply connect to our storage, for example, an interface. And notice this is connected here, but we can go ahead and separate that with a cable anchor. Actually, you know what would be better to do? Let's go ahead and remove this. We'll just take a cable, let our network reboot, cable, there we go. And we'll just bring this up here, right? So I'll just bring this up, and then what I'm gonna do, this line is connected to the main network. I'm gonna place an interface, and then on the new network, we're gonna place a storage bus that is connected to our interface. And you can see right here, this is recursive networking. It's already detected that we've done this, and it is pretty cool what you can do. Let's take a regular cable, and we're going to connect this up. Now, so what this basically does is this is a separate network that is detached from our main one, but it is powered, and it is reading the contents of our main network. Now, this will not allow you to request autocrafts, but it does allow you to access all of your items. And the best way to see this is by simply placing a terminal on the new network. And whenever we open this up, we can now see all of our items that are stored in our main network. Pretty cool. And this is actually a fundamental part of how the subnetworking works. So now let's get these bad boys hooked up. So essentially what I want to do is I want to run the product of the enrichment chamber over here. Now, a problem with this is our extra line here doesn't have anywhere to store anything. So if I want to, for example, put an exporter here and I have an importer over here, well, there's no internal storage, so it's not reading anything. But what we can do with these particular machines and on the subnet is we can use storage buses. So we can just account as the output buffer here. We just account that as the storage that is holding our products. And so I can use this just like so, and you can see now we have our ME storage buses here. And what I'll do is I'll connect them in, and this gives it a storage to look into for the exports. So now all of these, when they start working and they start building up with this enriched redstone, we can go ahead over here and we can put export buses that are up top. And these export buses, we essentially just need to make it that one item. In this case, this one is set up to utilize the redstone. So we're going to use enriched redstone. So we just drag that from JEI into here, and that should hopefully distribute all of that enriched redstone into the buffer slot here as it starts to build up. And now remember, to get a sense of what is actually being stored here, you can always place down a line and slap a terminal on it, and this will allow you to see what everything else can see. For example, it sees this forge energy. I'm not actually sure how this is in here. This is actually a part of another thing, which we actually don't have set up just yet, but it is a part of the flux. And I'm surprised it actually shows up here, but it's a part of the applied flux, which I do kind of want to get into and would technically allow us to power our Mekanism machines through these export buses and all of these other components. So now with this, I essentially need to set up the same thing. So I need to use these storage interfaces, and I'm just going to attach them to the top of my enrichment chambers. And yes, including the enriched obsidian one, because this essentially will be an output, but we're going to use the cable up here to actually connect down into here. And this will actually allow us to send with exporters the required ingredients that are going to be for this, which will be processed over here from this particular setup. Now, this refined obsidian was a little bit more complicated to kind of work out. So essentially up top, we still have the same sort of setup. We're inputting into the enrichment chambers. That all is well and good. And that is all working. But right here, I'm taking the ingredient that we see right here and putting a storage bus on here. And that then gets carried into this machine. Now we're already exporting into here from the same network. We're already exporting, or at least into the top, right? We should be sending two different things, right? We're sending diamonds that you can see right here, and we also have our obsidian that is going into this. And of course, once everything is fully powered, this should all start to jump on and run. But on the bottom here, I connected back into my main system with a storage bus. And this is kind of good because this refined obsidian that we're producing here has a secondary use, and that is in the osmium compressor to make refined obsidian ingots. And so I'm utilizing that, and I'll be able to utilize that later on for some other automation. But for now, I'm able to just tap in with some exporters down here and send in the refined obsidian to then be processed into the enriched version. And this is to save on resources later on whenever we go to make our atomic alloy automation. Now, I've done all of this automation, right? But this is like a high scaled up version of all of this. It is a little bit more complicated, but this is going to produce materials so fast. So we can scale up any Mekanism process indefinitely from this. So now with all of that up, remember that this was not to keep them constantly in stock. However, we can do that with a requester, and with this system will work really good. But this honestly makes the autocraft for any of this stuff very easy. I mean, we literally just need the base ingredient and what it outputs. We don't have to worry about the secondaries because those are all just constantly flowing in. So yeah, we don't have to worry about the fluid type or anything. It's just simply doing this right here. So one into the other and so on and so forth. Pretty straightforward, and everything should sort of handle itself. By the way, I'm holding shift and I'm left clicking in order to remove that, which makes that very easy. So these are just the base components. Now steel, we have to create a recipe for the steel blend. Not this recipe. We're going to need the metallurgy and fusion version. So we are going to need enriched iron. So that's our first step, right? And so that will make enriched iron from that recipe. And then the actual blend itself is going to go right here. And this is also going to get removed. And that's basically it. I wanted to automate all of the base alloys, which you see right here, and also steel, which is like fundamental. And just to kind of put this in perspective, this was the original simple automation that you can do. And I had all the patterns in here set up just using one infuser and one enricher. And then also the compressor, which we're still going to keep the compressor recipes and everything here because that still works just fine. But we don't technically need this anymore, and I will be removing that because it has been taken over by this much, much larger scaled up version. Oh boy, this is a much larger setup. And I love that I put these item frames here because it really makes it easy for me to just place the patterns in. Now I will have to go in here and update the pattern. And we also want blocking mode enabled. So what this will do is it'll only push what this can hold, and then it'll fill in the rest of the machines. So if we request like, I don't know, 900 of these, for example, it would distribute it through all 4 of these. And I am going to be upgrading these to max tier along with those cables as well. But we definitely need all of these in blocking mode. And this is how this is going to work. This one is this new pattern. And we can also set these patterns, by the way, to do 4 at a time if we really wanted to. I don't know how much that is actually going to help. But like I said, we'll see how it goes. But thankfully, we have an easy way to simply multiply the values on these patterns. So I guess now, without further ado, we should go ahead and test this out and make ourselves some alloy. So atomic alloy should now show up, and I can middle click, and let's just, for example, say, we want 10 of them. So that should jumpstart, and you can see right here that did fill up, that filled up, that filled up, and this back here would fill up if we had more to request. So yeah, if we had more already ready to go. So this is all going to make it much simpler for me to upgrade these machines, and I'm going to be getting all of those upgraded. It just takes a little bit of time, and I have to craft out all of these basic installers. So I know that I have 7 machines. So it should be 7 times 4, and we have 28 individual machines. And then we also have these machines as well. So we should have 48 upgrades we're going to need on each tier. And this setup is going big or go home. I'm not looking very big right now. There we go. Back to normal. Now, I know earlier I recommended blocking mode, and I honestly thought that blocking mode would be faster for this, but I was entirely wrong. This needs to be just left alone. You don't have to configure anything. I was under the impression that blocking mode was required for this. Yeah, like I said, definitely is not. And this works just fine with it off. Actually, it works much faster with it off. Now, I think for the other method, though, that I was using with the single machine, now that one requires it to be in blocking mode because you want to make sure that it's not sending 2 recipes into multiple slots, which could definitely cause like an issue with the crafting recipe. But these are all set up with individual machines, so it should all work. So let's try some steel, right? I've not crafted any steel yet, so let's do like 30 steel, for example. And this should jumpstart, and there we go. Look at that. We already have all of that ready to go. It's already pumping out the enriched iron, which is coming from this, which takes that in. And yeah, this is now producing that steel dust. Now, something neat I kind of want to show you, which has been a thing forever with Applied Energistics. If you go in here and, for example, speed upgrades is what I want to craft. I know how many machines I have. For example, I have 48 machines, and I know that I'm going to need 8 per machine. I can actually do 48 times, and then I can do 8. And this will simply do the math for me, which is 384, and it will request that many. I think that's pretty neat, the fact that it can actually do that, and I just wanted to show that. So now all of my machines are max upgraded. I got my cables upgraded as well, so the buffers should start to fill up on this. Now, I may have to actually exchange these out, because the more I look at this, the more I'm like, yeah, I don't think this logistical transporter is fast enough to actually keep up with this, but I do know what pipe would be fast enough, and that is the pipes mod at 100% would be able to keep up. It is keeping up with this one machine, and of course, once this buffer fills up, all the buffers will fill up, and I might just leave it at that, because that's a lot of residuals that are going to be stored in there. But I will say, all of this setup, all of this that I've done, this has got to be, you know, in each episode I try to expand on my setups. This is going to be one of the largest alloying facilities I have ever made. And I think it's because of the space, right? I have a lot of space to put all of these machines, and this has to be one of the biggest processing facilities that I've done for Mekanism alloy, and I think it looks phenomenal, and it's going to be also incredibly fast because of course having this back buffer is going to make this incredibly fast. Now, one thing I did want to try, each of these have 7 slots, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, they have 9 slots in the maxed out infusion factory. So what if I each craft set this up to do 9 times 4, and that's what our pattern process is set up to do. And so I should be able to modify this and get this up to a process of 36. So if I keep multiplying this and multiplying it, I'm at 32. Now I'm at 64. I wonder if I can get this number to 36. You know what? Actually, just leaving it at 64 might also be pretty good. And I can test this out, right? So I'm going to put this in here, and I'm going to say alloys, right? When I do a request for an alloy, even if I request 1, it's going to pull 64, and that should fill all of these machines. Oh, it doesn't fill all of the machines. Now, this might be where blocking mode would take place. Okay, let's try this again. Okay, so blocking mode still did not do that. It only sent it out to 1 machine. That is very interesting. Now, I think I can get this. If I put this in blocking mode and I get this set to, for example, 9, that could actually play a much better role. Like if I change these, I'm supposed to be able to middle mouse click, by the way. And I think if I go into options, controls, and I find what key middle mouse button is set to, let's remove that. Sort backpack, sort storage, sort item under cursor, like all of those things. Let's go ahead and remove that. Block pick should be fine. Then I should be able to modify this recipe. There we go. And I set this to 9. Like, and then blocking mode might actually work a bit better. Let's try this again. So I will request like 100. And now will it evenly divide? Oh, it does. Okay, so that is the magic way of doing that. Oh, that was so quick. So blocking mode is 100% the way to do it. However, you do have to make sure your pattern reflects the amount of slots that each machine has. So now after a little bit of decoration, these bad boys are looking pretty good. I just placed in some of these dynamic edge lightings. I have the light slab right here. And that's basically it. I'm gonna leave them the way they stand. I think they look pretty darn cool. And so with that, I hope today you learned something new, whether that was about applied energistics or whether it was about how point-to-point networks work or how subnetworks work, or even how to automate in a very complicated but incredibly quick method for the Mekanism alloys. And guys, of course, if you did enjoy today's episode, be sure to click that subscribe button, give this video a huge thumbs up. And with that being said, it's now time for me to thank the amazing supporter of today's episode. And that huge thanks is going to go out to Misfit343. Thank you so much for your amazing support, by the way, choosing to support me over on the Discord by becoming a Discord premium member and supporting in one of the best ways possible. I thank you guys so much. Join the Discord if you haven't already. Check me out over on Twitch, twitch.tv/ChosenArchitect. You can find me roughly 3 days a week, and I will hope to see you in the next episode. And of course, as always, thanks for watching. Bye!